Inside the shadow of Geneva, under the world's surface, lies a miracle of human cleverness and a potential harbinger of obliteration, the Tremendous Hadron Collider, LHC. This machine is a remarkable gadget for specialists, enabling them to study subatomic particles and reveal the mysteries of the God particle, the Higgs boson. Well-known physicist Brian Cox has made a chilling statement that has mixed marvel throughout the strict community, suggesting that something huge has been found at CERN with implications beyond our current understanding. Before diving into the repercussions of Cox's assertion, it is essential to grasp how the Large Hadron Collider works. The LHC is a 17-mile ring of superconducting magnets and the world's most powerful atom smasher. It stands as a peak of human achievement, capable of duplicating the states of the universe's creation. This titanic design permits us to unlock the secrets of the universe, uncovering something real and potentially upsetting. CERN, established in 1954, is one of the world's most renowned research institutions, containing 23 member states and a massive scope of experts. The LHC is CERN's central project, but it is just one piece of a wide network of accelerators and detectors that explore the subatomic world. The LHC accelerates protons to practically the speed of light, reproducing the energy of the universe at the time of the Big Bang. The resulting collisions produce temperatures thousands of times hotter than the sun's core, with a complex arrangement of magnets coordinating the protons on their journey, while advanced cooling systems maintain the magnets at temperatures colder than space. The LHC's design is an engineering wonder, working deep underground and shielded from cosmic radiation. The whole ring is cooled to a temperature colder than the vacuum of space, which is essential for the superconducting magnets to operate. Impacts happen at 4 points along the accelerator ring, each corresponding to one of the 4 principal particle detectors: ATLAS, CMS, ALICE, and LHCb. These detectors capture the fallout of collisions, allowing scientists to sift through the debris, looking for the elusive Higgs boson, a particle key to our understanding of the universe's structure. The LHC isn't merely a scientific instrument but a testament to human creativity and ambition. It represents our quest for knowledge and our desire to grasp the fundamental forces shaping our universe. However, as we push the limits of our understanding, we must also consider the moral and existential questions that arise. What are the risks of exploring the unknown? Could our quest for knowledge inadvertently unleash forces beyond our control? Within the hallowed halls of CERN, where the frontiers of human knowledge are continually expanded, a revelation has emerged that has sent shudders down the spines of even the most seasoned scientists. Brian Cox, a former scientist at CERN and a respected voice in particle physics, recently made a statement that has both astonished and terrified established researchers. The goal of CERN's Large Hadron Collider is to reproduce a scaled-down version of the Big Bang, the event that birthed our universe. Cox also highlighted the potential consequences of this goal, noting the LHC's ability to create new phenomena, including its potential to uncover the Higgs boson and study dark matter, a substance that comprises a significant portion of the universe. The possibility of reproducing a miniature Big Bang is not just a theoretical idea. It is a tangible reality within the LHC. The conditions inside the collider mimic those that existed at the universe's beginning, allowing scientists to observe the emergence of existence itself. However, with such power comes great responsibility and potential risk. Consider the situation where something goes wrong. In 1978, Russian physicist Anatoly Borodov experienced an accident at the Institute for High-Energy Physics in Russia, where a glitch caused his head to converge with a proton beam, resulting in severe injuries. Despite this, Borodov survived and continued his work, highlighting the tremendous power and possible dangers of particle accelerators. The risks associated with a particle accelerator like the LHC are not to be taken lightly. The potential for unforeseen reactions and the manipulation of the very fabric of reality are legitimate concerns voiced by some in the scientific community. One of the primary fears surrounding the LHC's experiments is the possibility of creating miniature black holes, regions of spacetime with such strong gravitational pull that not even light can escape. If the LHC were to produce such an entity, even on a small scale, it could potentially consume the Earth from within. However, researchers at CERN have assured the public that any black holes created would vanish almost immediately. Understanding how the LHC could create a black hole involves the fundamental mechanics of particle accelerators. When protons are smashed together at near-light speeds, the energy is so immense that it could warp the fabric of spacetime itself. Imagine a trampoline stretched tight with a heavy weight dropped onto it. The surface would bend. If the weight were sufficient, it could create a hole. This analogy illustrates the LHC's potential to generate a gravitational anomaly. This intriguing yet disturbing possibility has indeed captured the attention of prominent physicists, such as the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at extremely high energy levels, potentially causing a catastrophic vacuum decay, a massive event that could annihilate the universe. Renowned cosmologist Sir Martin Rees has also expressed concerns about particle smasher experiments, including those at CERN. In his book Our Final Century, he reflects on the potential risks involved. Dangers of molecule collider tests. Counting the arrangement of vacuum. Precariousness. This flimsiness could theoretically trigger a stage progress that would echo through spacetime, causing a fiasco of incomprehensible extents. While these situations remain profoundly theoretical, even a remote chance warrants serious thought. The stakes are amazingly high, and the edge for blunder is razor slim. The specialists at CERN have fastidiously surveyed the potential chances related to their tests and carried out various security conventions and shields to mitigate any potential risks. However, logical investigation innately includes a level of vulnerability, particularly while wandering into unfamiliar domains. The pursuit of knowledge has forever been accompanied by gambles, but it is exactly this readiness to push limits that has driven human advancement. The LHC represents the culmination of many years of logical progression and global cooperation. Yet, underneath its great outside lies a space of significant logical request loaded up with potential risks and moral contemplations. The collider's essential objective of disentangling the secrets of molecule physics has prompted striking revelations, including the subtle Higgs boson. However, the massive energies created within its limits also raise concerns about the possibly lamentable consequences of such an undertaking. While broad security measures are set up to mitigate risks, the chance of devastating events, such as the making of infinitesimal black holes or other unexpected peculiarities, can't be totally precluded. As specialists proceed to push the limits of our comprehension, it is significant to approach these examinations with a sharp consciousness of the likely results and a commitment to transparency and public discourse. The LHC, with its unmatched capabilities and potential for historic revelations, remains a demonstration of human inventiveness and the tenacious quest for figuring out the essential laws of the universe. However, underneath its dazzling exterior lies a domain of huge logical request packed with possible dangers and moral contemplations. The collider tests tap into energies and powers that are outside the ability to understand of generally lay individuals. The impact of subatomic particles at close to light speeds makes conditions similar to those that existed in the universe's earliest minutes, permitting analysts to test the major building blocks of matter and explore the actual texture of spacetime. Yet, the huge energies associated with these crashes also present critical dangers, both known and obscure. Quite possibly of the most squeezing concern surrounding the activity of the Large Hadron Collider is the likely formation of miniature black holes or other outlandish peculiarities that could have unanticipated results. While hypothetical models suggest that any such black holes would be vaporous and represent no danger to Earth or its occupants, the possibility of accidentally releasing powers beyond our control remains agitating. Also, the sheer scale and intricacy of the tests led at the collider require thorough well-being conventions and oversight to limit potential dangers. The worldwide local area of researchers and analysts engaged with the collider's activity is very much aware of the need to focus on well-being and ensure that all investigations are led with absolute attention to detail and responsibility. The Large Hadron Collider, with its amazing skill to test the texture of truth, isn't just a wonder of current engineering, but also a central mark of contemporary material science and cosmology. Its essential goal to explore the fundamental particles that make up the universe has huge implications for how we might interpret existence. The LHC enables researchers to reproduce conditions just minutes after the Big Bang, providing a unique opportunity to concentrate on the boson and other major particles. The Higgs boson, often referred to as the God particle, was conjectured in 1964 by Peter Higgs and others as a critical part of the Standard Model of Molecule Material Science. This model describes the key powers and particles that comprise the universe. The disclosure of the Higgs boson at the LHC in 2012 affirmed the presence of the Higgs field, an undetectable field that gives mass to various particles. This disclosure was a fantastic accomplishment, approving many years of hypothetical work and enhancing our understanding of the universe's fundamental structure. However, similarly to all critical logical tries, the quest for knowledge at the LHC isn't without its true capacity risks and moral dilemmas. The energies associated with molecule crashes at the LHC are tremendous, and the chance of making new types of matter or setting off unanticipated responses can't be totally excused. Some scientists have speculated about scenarios in which high-energy crashes could deliver miniature black holes or other extraordinary substances, raising worries about the possible results of such occasions. While most researchers consider these dangers to be incredibly remote, the very nature of logical request includes wandering into the obscure. Brian Cox's declaration, highlighting the chance of reproducing a small Big Bang inside the LHC, emphasizes the significant importance and possible risks of this exploration. The Large Hadron Collider addresses the apex of present-day logical endeavors. However, its momentous capacities also spark a critical conversation about the limits and obligations of logical investigation. The Collider, through its plan and activity, seeks to answer major inquiries about the universe, but it operates at the outskirts of human knowledge and innovative ability. This convergence raises significant inquiries about the nature of logical risk and the moral ramifications of such high-level examination. Quite possibly the most energizing part of the LHC is its capacity to reproduce the circumstances just minutes after the Big Bang, providing an interesting look into the early universe. This reenactment permits researchers to concentrate on particles that existed in the early-stage universe and examine peculiarities that would generally be blocked off. By imitating these outrageous circumstances, specialists can test hypothetical expectations and refine models of molecule physical science. For instance, tests at the LHC have the potential to investigate the properties of speculative dark matter particles, which are accepted to make up a huge piece of the universe's mass, but remain undetectable by conventional means. The journey to comprehend dark matter is driven by its significant ramifications for our grip of the universe. Right now, dark matter is surmised from its gravitational impacts on apparent matter. However, direct discovery remains elusive. The LHC's investigations mean to address this challenge by endeavoring to produce dark matter particles in the lab. If successful, this could disrupt our understanding of the universe and potentially lead to new discoveries and insights. Such forward leaps highlight the LHC's role as a scientific instrument and an impetus for groundbreaking discoveries that could reshape our perspective. Another interesting area of research is the exploration of the strong force, one of the four key forces in nature. The strong force ties protons and neutrons inside the atomic core, and figuring out its behavior at high energies can provide insights into the key structure of matter. The LHC's capacity to test areas of strength at phenomenal scales allows specialists to explore the interactions among quarks and gluons, the rudimentary particles that mediate the strong force. These examinations could lead to a deeper understanding of atomic physics and the forces that govern the behavior of atomic cores. The innovative advancements driven by the LHC also have sweeping ramifications beyond particle physics. The Collider's complex systems for detecting and analyzing particle impacts have spurred advancements in computing, data analysis, and sensor technology. For instance, the development of the World Wide Web was initially conceived as a method for researchers to share information from particle physics tests at CERN. Today, this technology has transformed global communication and information sharing. The advancements in computing and data management expected for the LHC have had an increasing influence across various fields, showing how major scientific research can drive technological progress. However, the operation of such a powerful instrument requires robust safety measures and ethical considerations. The potential for startling outcomes, like the creation of new or exotic particles, requires a careful evaluation of risks. While hypothetical models suggest that the chances of devastating events are very low, the possibility cannot be totally excluded. This uncertainty demands that specialists approach their work with mindfulness and transparency, ensuring that safety conventions are vigorous and that the public is informed about potential dangers and the actions taken to mitigate them. Public engagement and understanding are significant parts of scientific research, particularly for projects with the potential to impact society at large. The LHC has generated significant interest and conversation, highlighting the importance of conveying complex scientific ideas to a broader audience. Effective science communication demystifies research and fosters informed public discourse about the implications and risks related to advanced scientific investigations. By maintaining an open dialogue with the public, researchers can address concerns, dispel misunderstandings, and build trust in the scientific process. As we move forward, the continued operation of the LHC and the potential for new discoveries raise significant questions about the future of scientific exploration. The collider's capacity to test unfamiliar domains of particle physics might lead to new inquiries and challenges, pushing the limits of our knowledge even further. The quest for these frontiers will require ongoing collaboration among researchers, engineers, and policymakers to ensure that research is conducted responsibly and that the benefits of scientific advancements are maximized while minimizing potential risks. The LHC stands as a symbol of human ingenuity and the persistent quest for knowledge. It represents a convergence of cutting-edge technology, theoretical physics, and global cooperation, epitomizing the collective effort to understand the universe's most profound mysteries. As we advance in our exploration of the fundamental forces and particles that shape our reality, it is essential to remain mindful of the ethical implications and potential outcomes of our collective endeavors. The Large Hadron Collider remains at the forefront of scientific inquiry, offering exceptional insights into the nature of the universe. Its experiments have the potential to unlock new domains of knowledge, drive technological advancements, and reshape our understanding of existence. Yet, with its phenomenal capabilities come significant responsibilities. The pursuit of knowledge must be balanced with a commitment to safety, transparency, and public engagement. As specialists continue to explore the frontiers of particle physics, the LHC will remain a testament to human curiosity and the mission to unravel the fundamental secrets of existence.